Hello. So today we are doing this problem called Sqrt, problem number 69 from Leetcode. So let's get started. So the problem says that we want to implement the square root of x, and we are guaranteed that it's a positive value, and we want to return what we want to return is an integer. So basically we would need to truncate the decimal digits and only return the integer part. So for 4, for example, it should be 2. Just verifying that the stream is live. Yes, it is. Okay. So and for 8, we should return 2. That's basically the problem here. So how can we solve this problem? So one way we can do this is by just doing binary search. So we know that the square root of x is probably a value that is less than x, between basically 1 and x, right? So we are sure that the square root is, so for a number that is, so x is, we know that x is non-negative, so x is, so we are guaranteed to be non-negative, so x is bigger or equal to 0. So if x is 0, then in that case we'll get 0, and basically the square root, let's call it here, this of x is between 0 and x, depending on the value of x, basically. So let's get started and see how can we solve this problem. So we can do binary search on this range because this range is sorted, right? It's a list of consecutive values. We have 0, 1, 2, 3 until x, right? And so we can just do binary search on this, right? And so let's start immediately with the binary search template. So just notice one detail here is that if x is equal to 1, then the square root of x is 1. So sometimes there are cases where the square root of x is x itself. So we need just to think about that when we declare our boundaries. So our boundaries is lower and higher values, and we know that it can be 0, but the higher value that it can be is not x, it's x plus 1. Because high, in order to be able to get this value, we need to go as, so if it was an array, we would have done length of the array, right? But since the array now is all of this, its length is x plus 1, right? So we need to just do x plus 1. And for binary search, we just keep trying as long as lower is not equal to high, and we calculate the mid value. For the mid value, just to avoid having integer overflows, we can just do something like this: high minus low divided by 2. And now we do the binary search property check. So basically what we want is find the first occurrence of a number that is bigger than x, right? Because that is, so basically we want to find a number mid such that if mid square is bigger than x, if we find this, then that means that we need to go left, right? Because going right will only increase the value. Now if we find that mid, so this basically means explore left. Now if mid square is less or equal to x, so it's either the value itself is where we are, or it's on the right, because if we go left, we will only find the smaller values. So we need to explore right and stay on the middle, because that may be the solution, right? So the way to do that then is we do exactly as we said here. So if mid square is less than or equal to x, actually it's what I said here is wrong. We can do it here instead. So stay on mid, because maybe it's maybe that's the solution. Maybe we won't find something better because of these values after the basically because of the decimal digits. And so we can do like this. So if it's this case, then we have low equal to mid plus 1. Basically, if we do mid plus 1, that would allow us to go left. So if we do mid plus 1, if we put the lower value at mid plus 1, so let's say we had mid here and we had low value here, right? So if we move low to be mid plus 1, that means we will explore, and high is still here. That means we will explore the right portion, right? Which is what we want to do. We want to explore the right portion. Now, otherwise, then what we need to do is explore the left side. So to do that, we need to do the reverse. We need to move high to the middle so that we can explore this, right? And so we need to do this. And at the end, we can just return low, but because I did here x plus 1, I want to return lower value minus 1 so that we can find the exact value. Now let's run this and see if we, what's the issue? We have invalid syntax. Yep, we need this. Okay, so yeah, seems like there is an issue in the solution here. Yeah, so my division here may give me like values with point that are not integers, so I'm going to do this to avoid that. Okay, so that passes for 4. Let's test out 8. Let's test out 0. Okay, so 0 passes. Let's just test out, just to be careful and test the boundaries, let's test out max int value. Which is something like this. It's just Python, so it's probably not a problem, but it's just easier to be sure. Because we are doing +1 here, I'm afraid that we might overflow, but with Python, it should be fine. Yep, okay, there's no difference. Cool. Submit this. Okay, so this solution passes. Now, let's think about another way to solve this problem here. So Python has, let me just open the terminal here to show something. So Python has this bisect function where it has let me see, bisect. So import Yep, so bisect right, let's see. Okay, so bisect right, we give it an array or a set of items, and we give it the value we are looking for. We give it like boundaries, and all of these are optional. And basically, it returns the index where to insert the item X in that list, basically. And it assumes that that list is sorted. The return value is, well, here it just gives the properties of the return value. So let's try to use that, basically. So the way I'm going to use that is using just a special trick, because we don't have here a list, right? We have just the value X. So we need a way to, I'm just going to, basically this solution is just avoid needing me to write the binary search myself and just use Python's built-in functions. So the first thing would be to import bisect. And what I'm going to do, so basically this is a trick when you don't have like the list, you just have some operation or some property for binary search, like it is the case here. We just know that the value that we want to find, we want that if we square root it, we want to find x. So the way I'm going to do that is just I'm going to create a class. It's called just wrap. And when it gets asked for an item, so it's just going to act like a list. And when it gets asked for an item, it's going to return whether that value is bigger than x. So basically we know that as soon as we pass this condition, that means that the value we are looking for is before that. Yeah, it's before that. And so basically what we want to have happen is something like this, where we have false, where we have false, 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 and then some true values start happening. And so this is what we want to detect. So this first true here is what we want to detect with this here. So once we get this true here, that means that it's the value right before that is what we are looking for, because that's the value where it's equal to x, right? Because here we got the first value that is bigger than x. So the value just before that, that's what we are looking for, right? So the way to do that then is we are going to call bisect. On bisect we are calling, basically this one here is bisect right, which just means that it will find the first value that verifies some condition. And we are going to call our class here that returns this. And what are we looking for? So actually, sorry, so we want to find the first value that this is false at, right? Yep, we want to find the last value that this condition is false at, right? Which means basically that we find the value that it's true at, the next value is the value where it's true, right? And so what we want to do is we want to keep looking for false, and since we are doing bisect, so if we go here bisect right, so it returns the where to insert it. So basically if we find, so it will tell us where to insert, which would be somewhere here, because if all of these are false, it will say, okay, you need to insert it here, right? We need to insert it here at this position. And so in order to find the value that is equal to x, we just need to go -1. And so I will keep looking for false, and with bisect right it finds the last false. I can just take that value and do -1. Now what are the boundaries that I need to pass? These are the same boundaries that I've used earlier, which are 0 and x plus 1, so that we can find the value x. And yeah, I hope that was a little bit clear. I hope that. And so let's run this and see if it works. It's complaining that, yeah, let's define this class wrap inside the function itself instead. Okay, so it works for that. Let's try with 0. Okay, let's try with 4. And let's try with 8. Okay, so that seems good. Let's see if this passes. Okay, it does pass. Good. Okay, so now one last solution that we can look at that it doesn't use binary search at all. It uses something called Newton's method. So Newton's method, which basically is just a way of finding a root. So it's just a root finding method or algorithm. And the way it works is that we have a function f of x, and we want to find the values, just find, let's call it xi, such that, or I don't know, like xs, such that f of xs, which is the solution here, is equal to 0. So just find the value where the function is, the function value is 0. So in our case here, what we want is we want to find a value, let's call it G as guess, or just like maybe let's take another thing. Let's say the value A, such that A squared is equal to X. This is what we want to find, right? So our function here, f of x, that we want to find the root for is a of x squared minus x, because if this is equal to 0, if we find the value x such that this is equal to 0, then we found a, right? So if we find here, if we find a, then yeah, that's what we want here. So we convert this equation to finding the root of this function here, right? And so basically with Newton's method, you can look it up online for explanations, but the gist of it is that we can approximate the value x by doing multiple guesses, and every time we improve our guess. And so basically the way we improve our guess is using this formula that x of n plus 1 is equal x of n minus f of x divided by f prime, which is the derivative of x of n. And this is f of x sub n. And this here, you could see an explanation of it online, but it's just because this is every time we find the f of x sub n, we just take the tangent, and with a simple formula using tangents, we can find this formula basically. But going from this formula, let's try to see how can we use this as an algorithm to solve our problem. Okay, so f of x sub n here is equal to x of sub n squared minus x, right? I'm just going to replace x here with s, because just to not get confused with this f x sub n. And we want to find this equal to 0. What's the derivative of x sub n of this here? It's just 2 multiplied by x sub n. This is a simple formula for with the full derivative, right? Now from this, what do we have? So from this, we know that x sub n plus 1, we're just gonna plug this into this formula, right? So we have this formula, so let's just replace values. So we take this, and this is equal to x sub n, sorry about this, x sub n minus this value here. What is f of x sub n? That's this, without the 0, of course. So that's just this divided by this, right? Now we can just do a couple of substitutions. So this is equal to 2x sub n squared. So I'm just going to multiply this with this, and then multiply this with 1. Just your normal like operations with the value and the ratio, basically. It may be hard to look at like when it's written like this, but you can just do it on paper and it would be very straightforward. So this here multiplied by this minus this, which means it's x sub n squared minus s, and the whole thing would be divided by 2 multiplied by xn, which is this here, right? And so let's just simplify this a little bit. So if you simplify this a little bit, we will get that it's equal to So this minus this, that's just x sub n squared, right? That's just x sub n squared minus s, and the whole thing divided by. Actually, I made a mistake. So if we do this, it becomes plus s, and so it's plus s divided by 2x sub n. And now this is equal to, if we just divide both here and here by x sub n, that's that will give us x sub n, because this is squared. This is yeah, to the power of 2 plus s divided by x sub n, and the whole thing divided by 2, because yeah, this one we divided here and here. And from this formula here, we can start doing our function. So we end up with this. And so basically, every time we are improving our guess, so basically the Newton method is just keep guessing until finding a solution that is good enough. That is good enough. And good enough here just means that such that the difference, the absolute value of difference of the guess squared minus x is really small. It's like less than some epsilon value or some delta value, right? And so the way we are, every time we are going to improve our guess is by doing this formula here, such that x of sub n is the guess before, so x of n is the previous guess, and xn plus 1 is the new guess. X sub n plus 1 is the new guess, right? Which here is exactly the formula we are using for with Newton's method, that says that get a new guess that is closer to the value by taking the previous guess minus this value here, okay? And so this is exactly what we are going to do here in code. So our guess would start out to be x itself, and then from there we would keep improving our guess until we get a value that is closer to the square root of x. And the epsilon value we can just take, that we are going to use to know if our guess is good enough. We're just going to take a small value, which is 0.0001. And from there, our while loop would just use this formula that we said here, which is while epsilon here, guess squared minus x is, so this means good enough. So while it's not good, which means bigger or equal to epsilon, let me just write this in Python, which is that. And so while that is happening, keep trying to improve our guess. And how do we improve our guess? Just by using this formula here and just replacing the values. So that means that the new guess, which is just while iterating, we're just going to replace guess, is the previous guess. So it's guess plus s here, which in our case here is just x, divided by the guess value here, and the whole thing divided by 2. So we just do the formula without thinking. And the final result that we return, once we exit this condition, that means that we found a value that is good enough. And so we can just return that as our guess. Okay, let's submit this. Okay, so that passes. Yeah, so that's it for you. We can solve this problem with either binary search or using Newton's method. And that's it. See you next time. Bye.